Overton, our President of Civil Aerospace, and Rob Watson, Head of Rolls-Royce Electrical, are going to talk through our sustainability strategy, and Rob's going to give a bit more of a deep dive into the electrical piece. Just the usual housekeeping, if you can turn your phones off, etc., that would be great. And we will open for Q&A when the gentlemen have finished their presentation, so you will have a chance to answer a few questions at the end. So on that note, we'll hand over to Chris.
Thanks, Daisy. That's my first few sentences gone, has it? No. So great to be with you again, and that's one of the things for this air show. I think it's great to reconnect with everybody. We're just saying a few of the people, familiar faces in the room, but it was probably a Singapore air show just as all this was starting off that we last spoke. So yes, we're going to take you through the sustainability strategy. I should say up front, we've placed sustainability absolutely at the heart of our group corporate strategy. I mean, you've got the words here and on the outside the building, pioneering the power that matters, and there's no question that the power that matters now is low carbon and the power and the driver towards net zero. We believe strongly in the transforming potential of technology to that aim. And of course, we're a technology company. Great engineering depth, and so we very much see ourselves as part of the solution. We see it not only as a societal imperative, but also as a commercial opportunity, given what we do. So we'll give you some of the examples of the tangible progress we feel we're making and really bringing this to reality. Let me kick off. First of all, let's talk about COP26. I think it was a really important session. It's probably a couple of things. One, I think in focusing a mindset of urgency, no question it achieved that, and also this focus on delivering a real result and the need to convert words into actions is very clear. I think a very strong private industry participation too. It's certainly been a catalyst for gaining more commitments of both corporates and of course governments to the aim of net zero. What we announced were a few things. One was the small modular nuclear reactor consortium, where we've secured £200 million worth of funding from the UK government and matched that with £200 million worth of private funding to really kickstart the programme to bring a small modular reactor to reality. And it was Sir Henry Royce who said, invent once and use many times, and of course that's a great example of it, because we have that technology from our nuclear submarine business, and now we can bring that to reality, both grid power and off-grid power. We're excited by it. It's 85-90% of these modular reactors are built in a factory environment and then assembled on site. So it's a tenth of the cost of a normal nuclear reactor, some 470 megawatts, and will be a key part, I think, of green power provision in the future. We also had an MTU, so Rolls-Royce Power Systems fuel cell on our stand. Rob will talk more about fuel cell technology, but this is an example for ground-based power, for microgrids, backup power applications, and we have a demonstrator of our fuel cell technology running in Friedrichshafen in our power systems business. We announced a collaboration with the Qatar Foundation to establish R&D centres in the UK, like in north of England, and in Qatar, to drive climate technology. So as a catalyst for startups, as an accelerator for some of those technologies, attracting more venture capital and such like. So we enter now a study phase to bring that to reality. But clearly we'll bring some of our technical and expertise. And also, a star of the little stand we had here was the model of Axel. This is the single-seater aircraft, electric aircraft. Rob will no doubt say more about it, which is currently flying to set a world speed record for electric flight. And records are always nice to set, and it's a nice catalyst for action. But of course, what we're doing there really is learning a lot about battery technology, the thermal management of batteries, the system integration, the power electronics, which will have other applications in eVTOLs like the one behind you and others. So very active at COP26 and bringing some of the technologies we're working to the fore. So our pathway now looking at aviation, because I could say as a group, it's not just aviation decarbonisation we're focused on, of course. We're looking at the decarbonisation of transport, of energy, and the built environment domains, given what the business does as a whole. If I focus now on aviation, three key pillars to the strategy. Firstly, it's to bring to market ever more efficient gas turbines. And this is crucially important because for flying a long way with lots of passengers, the gas turbine will be the source of the power for many, many, many decades to come. And yes, it will be powered by sustainable aviation fuel, which I'll come on to, but you need the gas turbine solution. And some 75 or 80% of the emissions in aviation today come from flights over around 1,300 kilometres. That's going to need a gas turbine technology. So, what are we doing? We're running a number of demonstrator programs at different sizes. The most notable one coming to the fore in the next months is our UltraFan technology, which can sail either for wide body applications or for narrow body applications. A 25% improvement from the first generation of Trent engine. And this is very real. I'll show you some pictures in a moment where parts are coming together, the engine's being assembled. It'll run next year, and we'll learn a lot from what we've got, but we're very excited to see that come together. We also have gas turbine technology demonstrators at smaller sizes too, sort of continuing to invest in the technologies that we know are very important across the various segments of the market. We're passionate about bringing sustainable aviation fuel to reality too. So what can we do? Well, we're demonstrating that our engines are compatible with 100% sustainable aviation fuel, and I'll perhaps talk about that a little more in a moment. And we're also trying to influence industry thinking. This was an example of a media day we had in Derby recently, joined by Airbus and Shell, just to talk more about the importance of SAF. Because the challenge here is going to be the scale-up. We'll shortly better demonstrate engines are all compatible with 100% SAF. It's all going to be about the policy and how we get the infrastructure scaled up to make those quantities that we're going to need a reality. And the third pillar are the disruptive technologies of electrification, of hybrid electric flight, and indeed of hydrogen, and some of the examples shown there, which Rob will cover more of. The Axel single-seater speed record, and here's the virtual aerospace urban air mobility application where we provide the electric propulsion system. So, and on hydrogen too, doing studies there either of gaseous hydrogen with a fuel cell, or indeed with what it would take to make liquid hydrogen and burning hydrogen in gas turbines a reality. I think one thing I'd say about all these technologies, the integration with an airframer becomes ever more important. I mean, it's important today, but as we get to the different technologies here, that close integration of the system solution is absolutely key. So let's now pick on a few of those and look in a bit more detail. These are some pictures of actual hardware of the UltraFan coming together. So on the left here we have the composite fan blade, carbon composite fan blade with this titanium leading edge, manufactured by automated tape lay. So robots really laying down 5mm strips of carbon very precisely. It's been developed over many years, as many of these technologies take to bring to reality. We're delighted with what we've got. That blade technology has flown, it's had birds fired at it, it's done all sorts of testing you'd expect on to validate a fan blade, a huge beast, and we'll come together in the UltraFan shortly. This is a composite fan case, 140 inches diameter. It's a very UK-based analogy, but for those who know the London Tube, a London Tube train goes through the middle of that fan case. Just look at the size of these outlet guide vanes in hollow titanium, and you get a picture of the scale there from the individual sat in the middle of it. This is the power gearbox. So in a 1 meter cube sort of size, we've demonstrated up to 87,000 horsepower. Way more than 500 family cars worth of power in a 1 meter cube. Technology has been developed in a facility in Germany, and all sorts of testing in a dedicated facility there to mature that technology, and we're absolutely delighted with what we're seeing with it. So that's another key step change in how we're tackling bringing the high propulsive efficiency to reality. So yeah, being assembled now, and we'll run and test next year. This is, so as well as trying to improve propulsive efficiency by a large geared fan, we're also working on the core technologies and ever smaller and hotter cores. We've run the core of the UltraFan already, and we ran that last year. and again, results perfectly in line with prediction, which shows the sort of strength of the digital tool sets we now have. Here's another example where we're running some high temperature technology in an adapted Trentex WB97, where we're running some advanced cooling technologies in the turbine, some different way of manufacturing nozzle guide bays in the turbine blades to improve cooling effectiveness, ceramic matrix composites for some of the static parts, and indeed a new high temperature disc alloy which increases the temperature capability of the core of the gas turbine. And so to SAF, we've been doing a lot of testing, both ground-based and flight testing on our engines. So we've made a commitment that by 2023, all our Trent engines and our modern business aviation engines will be demonstrated to be 100% compatible, with 100% sustainable aviation fuel. And so to that end, we've flown recently a Trent 1000 on our flying test bed, so demonstrating performance, demonstrating emissions, altitude relight and such like, and we learned from that. We've tested on the ground both Trent engines and Pearl engines from our business aviation family. We've flown the A350 in the first demonstration of a dual engine demonstration with 100% sustainable aviation fuel, and gained learning there. Our UltraFan will run on that first run, which will be a great moment for the industry. We'll run on 100% sustainable aviation fuel, etc. Safinity is a service we offer for business aviation customers where on their app, for the services we provide, they can conveniently offset their emissions with validated offset schemes or purchase equivalent SAF, amounts of SAF to offset the emissions of their journey. I think though, in ramping up sustainable aviation fuels, initially biofuels from various pathways, you need to be careful of course that those pathways are fully sustainable themselves and not taking away land from foodstuffs or from causing deforestation and such like, and so we will eventually run out or limit the viable pathways. And so what's really going to be important for the scale up we need is generating or creating purely synthetic fuels, and that's where the power to liquid sort of technologies become important, where we take hydrogen from the electrolysis of water, for example, green hydrogen, we capture carbon directly from the atmosphere and create a hydrocarbon. That takes a lot of electricity, and so shown there is an example of that small modular nuclear reactor I spoke about, where you could imagine that combined with a dedicated SAF plant to create purely synthetic fuel. And we're going to need that technology to get to volumes we need to scale up. I think in scaling up, a few things are going to be important. Clearly, some mandates to set the demand, pricing support mechanisms, policy from government, infrastructure investment from governments. There's a lot to do here in the scale up. We need 400 times the amount of SAF to hit the 10% commitment by 2030 that the commitment the industry has made. One more click. Right, changing gears, that third pillar now, and Rob's going to talk a lot more on this, but just as an introduction. So now I'm talking about the disruptive technologies of electrification. Here we have the world's most powerful hybrid electric demonstrator for aerospace propulsion, a 2.5 megawatt hybrid electric demonstrator, currently running on test in Bristol. It's already reached over 1 megawatt and will go and push on through its test program to reach the 2.5 megawatts. So again, the sort of technology which may find application in regional aircraft applications and such like, that's the sort of power size. We also, as Rob will talk, have hybrid electric demonstrators at smaller size too, which you'll find more for commuter aircraft or slightly bigger eVTOLs. So we're excited by this, and I think what we can bring here is the understanding and capability we have of how you actually bring a new product to market and certify it for aerospace application and integrate a complete system is what companies like Rolls-Royce can do. And I think that's where some of the immense challenges lie. So here's a good example where it's taken a number of years to get to this stage, and we'll learn a lot maybe through this test program, but the world's most powerful hybrid electric demonstrator. Briefly changing gear again, I just wanted to mention some of the other ways we work nowadays, which also help support a lower overall carbon footprint. The electronic tools that we now use are completely transformed from where they were a number of years ago. So we truly have now digital twins that go right through the manufacturing process and into service. I mean, there's a good example in some of our rotating parts where almost automated design for discs, which feeds straight to one of our factories, generating 100% right first time on many thousands of features in one of our factories in Washington and those parts. It goes into service. It's a critically life part, so a life limited part. And the lifing of that part, we measure its effectively life usage from what we know every single flight of that particular engine has done. So we can eke out ever greater times on wing of those components, and therefore have to replace them less often helps and reduce our costs, but also uses less new material in making new ones and such like. So the digital twinning now is pretty sophisticated. When you combine that with the intelligence we now bring to them, the data we collect off engines, as I've described, and some of the analytics we now apply, you can absolutely extend time on wing by some quite considerable margins, and of course by understanding the flight profiles, help airlines minimise their fuel usage. Our repair and overhaul strategy, which is obviously so key to our overall business model, also contributes. We're putting more of our global network closer to its point of need, so there's less transportation, reduces our transportation costs, but of course also saves carbon dioxide. And some of the repair technologies which we're investing heavily in, again, allow us to reuse more material rather than having to always put new material in. Again, good for us in helping our financial performance, good for the planet too. Here's a direct laser deposition repairing a seal segment. And we're also using digital analytics and some artificial intelligence to get far better knowledge of where all our service used material is and what life is left in it, so that we can reuse parts more than we do today. And we also have a number of partners who help us reuse a material and extract some of the very valuable rare earth metals from scrap material, so that we can recycle that. So 98% of our engines are recyclable. So, before I pass on to Rob, just a few words on our commitments we've made publicly. We've made the commitment on UCL demonstrating compatibility with 100% sustainable aviation fuel. We're going to use 10% SAF in all our own testing, development and production pass-off testing from 2023. We're shifting some of our capital allocation towards low carbon and net zero technologies, from about 50% we had before to about 75%. We've also committed that our own factories will be net zero carbon plants by 2030. One of them already is, the one in Bristol, in fact, and we'll continue on that journey. And indeed, all our products compatible with net zero operation by 2030. So I'm not just talking aerospace products, but the products in power systems too. There are also in our net zero report issued recently some other commitments on other parts of the business which you have access to. And we are a signatory to the US race to zero. So I said, repeating what I said at the start, we're placing this very much at the heart of our group strategy going forward. And I think with that, I pass on for Rob to talk more about that third pillar on electrification.
Brilliant, thanks, Chris. Thank you. So, hi everyone, so I'm Rob Watson, I'm the Director of Rolls-Royce Electrical. Rolls-Royce Electrical is an engineering group that sits in the group part of Rolls-Royce. We're not in one of the three businesses. Actually, our role when we were set up was to develop engineering capability that all three businesses could use to rapidly incubate electrical technology that the businesses could pull through in more electric products. You heard a little bit about that from Chris. And also where we have an opportunity to take that same technology and sell it into adjacent or new markets. And quite a bit of what I wanted to talk about today was around those applications in this advanced air mobility market. So broadly speaking, what we intend to focus on in Rolls-Royce is how we deliver differentiated technology into the marketplace. We're not a group which has delivered electrical products over a long period of time. We've always had electrical capability within our businesses, but about 3 years ago we chose a very specific focus to accelerate our capability to address electrification across all our markets, so particularly in aerospace, but also in our industrial systems markets, which I'll talk a little bit about at the end. And of course, in doing that, we wanted to follow that classic Rolls-Royce approach that with this electrical technology we could build modular and scalable technology. So we could build an electric machine which we could scale in size through hundreds of kilowatts, possibly up to megawatts. You saw the megawatt machine on test a moment ago. And also make sure that portfolio was modular as well as scalable. So we would have a battery, we'd have motors, we'd have some power distribution. So depending on the requirements of a customer, we could design and optimise a power or a propulsion system which our customers could use. So a family of technologies that we would develop in-house and then offer as a product as quickly as we could take it through a certification process. And of course what that gave us is an opportunity to address a range of markets. And when we were additionally thinking about how do we deliver a more electric engine, how could we use electrical capability to further optimise a gas turbine, over the last 5 years there has been this rapid acceleration in these new markets, whether that's urban air mobility or rethinking how new technology could open up markets like the regional air mobility market, journeys up to 500 nautical miles. Could this technology enable a different way of thinking about those markets? Could it unlock a different use case? Could it unlock a different way that we think about flight? And of course that's dovetailed perfectly with that renewed focus on sustainability and how we help address the emissions challenge in aerospace and how we support that drive to net zero by 2050. So from an electrical point of view in Rolls-Royce, we focus on some technology building blocks. So I've mentioned already